Okay, it's time for mole worksheet 4. This is some mixed problems. They could ask just about anything that has to do with the mole. Let's dive right in. Question number 1 is done for you. We'll be doing the odd ones. You have to do the even ones, but hey, there's only 2 of them. Question number 1 says, the reaction of magnesium sulfate with table salt, they must mean sodium chloride, makes magnesium chloride turn into a balanced chemical reaction. Well, all we have to do is put the numbers in front. There's our magnesium sulfate, there's our table salt, there's our products. Let's walk through it. Here, let's actually do it the fast way. Well, what's doubled up? Cl2 is doubled up on the left, so we'll put a 2 in front of the Cl. Sodium is doubled up, so that also makes it doubled. So that's it. Everything else is just one of each. One sulfate, one magnesium. That's the quick way to balance these. Question number 3. By the way, you'll have to do 2 on your own, but it looks like this will assist you with it because it's a similar problem. Can you see that it's moles to moles there? And the one that you'll have to do is moles to moles. So if you're struggling with it, recognize that mole to mole conversions are only one step, and oftentimes you can do it in your head. Let's see if we can. How many moles of magnesium sulfate must be used in order to produce 100 moles of magnesium chloride? They must be referring to this question. Whoever wrote this should have indented this to make sure you know you're referring to this question, or even said, questions 1 through 3, blah, blah, blah. Somebody didn't do it, and that would be me since I'm the one who wrote this. Okay, start with what you're given. That's the 100 moles of magnesium chloride. And we want to know how, I notice there's just a 1 in front of that. And how many moles of magnesium sulfate do I need to start with? Yikes, it sounds like it's just the same number. So answer 100. So there it is. You need 100 moles of magnesium sulfate to begin with. Nice and easy. Number 4 is done for you. Use the equation. We want to balance this. They didn't say it, but you better balance it. Let's try it. I see V2O5. I need 2 V's and 5 O's. So I'd start by putting V2. If I need 2 V's, I'd put a 2 there. If I needed 5 O's, I'd write 2.5 there. And most scientists don't like half a mole because you can't really have half an atom. So they double everything, and you get 4 to 5 to 2. Now here's a solved problem. You'll have to use that to solve number 6. How many moles of vanadium, that's for this question, should have indented, are required to produce 47 grams of V2O5? Okay, I see grams to moles. I know it's a 2-step conversion. I'll start with what I'm given, the 47 grams of V2O5. And then I will recognize that you need a whopping 182 grams of V2O5 per mole. And that is from 2 V's and 5 O's add up to 182. Look them up on your periodic table. Anytime you react a mole of V2O5, it requires twice as many moles of V2O5. That does, yeah, here. A mole of V2O5 requires 4 moles of V. There you go. And so that's doubling it. So when you do that, you find that you'll need 0.52 moles of V. This problem will be slightly different. This is grams to grams. It will be a 3-step problem, but you've been through problems like that, so I'm sure you can do it. This is mole worksheet 4.